Good morning, everyone. Today we'll be doing the simulation of inverters and seeing comparing the performance of the inverter. The first one we'll be simulating is a PMOS inverter. The second one is an NMOS inverter, and third one is a CMOS inverter. And finally, we will look into how to convert the CMOS inverter into a sub-circuit which can be called by other programs. So these are the three objectives that we have set for this experiment. So we'll start with the PMOS inverter. So we'll start with the new schematic. We select PMOS 4. Okay. Then we need a voltage source and then a ground. We need a resistor, gate of the NMOS. The negative terminal is connected to the ground, and the source of the PMOS is connected to the positive terminal, and the body is shorted with the source. We have the out terminal, and we also have an in terminal. We will just connect it with our input and out. Once our connections are done, we'll just press escape, give the values. This biasing source is a DC 5 volt. Input is a pulse. So we will take it as 0 initial, 5. The delay, rise time and fall time, we'll keep it as 0. T on is 25 nano. T period is 50 nano. Press OK. And this resistor, we will keep it as 1K. Once our connections are made, we'll just run it. So we'll do the transient response, and the stop time, we will keep it as 100 nano and press OK. So we'll just see what is our input. So we can see it's a pulse, zeros and ones, and correspondingly what is an output. So we see when it is high, it is low. When it is low, it is high, but not very high, but higher than what we have for the zero. So this is the disadvantage for our PMOS that we see. The difference between high and low is very small. Now let's build the NMOS inverter. For that, we'll go to the component, select the NMOS 4. Under resistor. Okay. We'll have labels, in label, and we will have an outlet. We also have the ground. Now we'll make our connections. We'll take the wire. Negative is connected to the source which is grounded. Again, we will give the 5 volt DC for the bias, and the input will again make it a pulse. Same config, same values as we have given, so that we can compare the results and see the response of PMOS inverter and NMOS inverter. Now we will run it. So transient 100 nano and press OK. Okay. So we haven't given the value to the R, and that's an error. So I just right click, give the value as 1K, press OK. Now I'll run. So we are able to run it. Now we want to see what is our input and what is the corresponding. So we can clearly see when it is high, the output is slightly lesser than the 5 volt. Good, but the lows are not good because and the difference between high and low is very small. So because of under the low condition, still so much voltage is there. So there will be a lot of. Now for the CMOS inverter, we need one PMOS and one NMOS. And again, we need the voltage source for the bias and the input. Now we'll make the connections, the negative of the battery, the source of the NMOS, ground, all are shorted together. Now the body is shorted with the source. Now the source of a PMOS is connected to the positive of the battery. The body is shorted with the source. The drain of PMOS and NMOS are connected. The gate of both PMOS and NMOS is shorted, where the positive of the battery input source is connected. Now we will just add the labels in input type and out, which is output. So our circuit is made. Now we have to just give the values to the biasing. Again, we keep it as 5. At the input, we keep it as pulse with the same setting. Our circuit connection is made. Now we'll just run it. Again, transient response, stop time is 100 nano. Press OK. We can input. So we can clearly see the difference between PMOS inverter and the CMOS inverter, which shows a clear demarcation between the lows and the highs, and clearly shows when input is high, the output is low. When input is low, the output is high. And we have a good difference between the high and the low voltage. Now, one last thing we will do is convert the CMOS into a subcircuit. So first thing that we will do is we'll first save it as and now what we will do is we will delete all the voltage source, the ground terminal and the bias. Instead of this, what we will do is just add some labels. So VDD, again we need to give it as an input. So I make it as an input. Okay. Then I need a ground. Keep in and out terminals. Now I'll just take the input and connect VDD to the terminal where I want this VDD to be connected and the ground. Once this is done, I'll again just delete this trunk. This is the circuit where we want that inside the circuit is a CMOS inverter, and we should be able to connect our input, output, VDD and ground and use it in any circuit. For doing that, the first step is go to the hierarchy, open the sheet symbol. So it will say yes. So can you see this whole circuit that we have made of inverter 1 is now converted into a sub-circuit block with a ground in VDD and out terminals. Now I'll just show you how we can use it in our circuit. So this is a new schematic. Go to the components, just click on this top directory. You will see two directories. One is in the download and one is documents LT-SPI. Go to the downloads, whatever sub-circuits you have made. So we have made inverter 1, just click it, okay. And now you can use it in a new schematic. So this is how whatever circuits we make, we can call it in the other circuits like functions or procedures that we have been using in all programmings. Same way we have sub-circuits in LT-SPICE, which these blocks can be called. We can also go to the view SPICE sub. So can you see it's a sub-circuit of inverter 1 with all the terminals defined and the circuit inside. So it has automatically made the model and we are just calling that sub-circuit. Thank you.